Hi students, welcome to our physics channel, Physics and Me. Now we are going to discuss about the topic called waves. Okay, in this, now I am going to explain briefly about what is meant by waves and what are the types of waves, and also how the waves are generated and what are the equations, what is the function of a wave. Everything we are going to discuss. First, let us discuss about the details briefly. Okay, wave means what? A wave is nothing but a disturbance created in a medium. Wave is nothing but disturbance. It is nothing but a disturbance created, okay, in a medium and propagates in that medium. That is called as a wave. You might have seen so many examples of waves. Consider a long spring like this. Consider a long spring like this. It's a very long spring, and assume that it is made up of some soft metal, some soft material. Okay, sling. Have you ever seen the sling? That. Now, from one end, if you just give a certain instantaneous force, suddenly, if you just give a jerk to it, okay, if you give a jerk to it from one end, then what happens? Then you can see some compressions. Okay, at some places these spring part will be compressed, and at some other places the spring parts will be at far distances, like these threads are there, no? Okay, now these will be at far distances. Okay, you can see somewhere compressions, and you can see somewhere there is a much difference between these two threads, these all these threads, right? So it will be formed like this. It will be formed like this. Again, compressions. Again, like this. Okay, now this type of arrangement will be generated in that spring. Am I right or not? Let us consider one more example. Water waves. Okay, suppose in a calm river, water is at rest. Water is not moving. Now, if you just drop a pebble on a pond, okay, if you drop a pebble, then what do you observe? There are some ripples formed around it. Am I right? That is also one of the examples of waves. And in gym, you can observe a person who is doing his gym. He used to take two ropes with his hands, and he used to create the waves like this. That is also one of the examples of waves. So there are so many examples. Am I right or not? In that, let us categorize. Let us first understand what is going. Is a disturbance going? In what form it is going? Okay, that disturbance is nothing but it's a form of energy. It's a form of energy, which means that from here to here, the energy is going. Got my point? And from here to here, the energy is going, or from here to here, the pressure variation. Okay, now the pressure, and there is a density variation. There is a pressure variation. There might be energy variation, like that. Whatever it may be, the wave is traveling from one place to another place. It's nothing but energy, or it's nothing but pressure variation, or it's nothing but density. Disturbance means these phenomena, okay, now these physical quantities. Right, now let us categorize the waves. Okay, according to the propagation through medium, let us categorize the waves into two types. First one is mechanical waves, Mechanical waves means what? First one is mechanical waves and the second one is non-mechanical waves. Mechanical waves means if the wave has to be propagated. Here, how do you observe the waves? Just in a medium only, no? What is that medium? It's nothing but the solid. Am I right or not? While the sound energy is being propagated like that, then even then also, same as this, compressions and rarefactions will happen. Okay, now that will be happened in the case of sound. Okay, now in air molecules that will be happened. Am I right? That is also, I mean, why is it happening like that? Why? Because see, if there is no medium, can the sound be propagated? It's a very fundamental question. We can easily say that the sound cannot be propagated without any medium. Am I right? So, if there is a medium, then only these waves can be propagated. Those are called as mechanical waves. Water ripples are examples. Same here, spring and air molecules are the examples. So many examples are there for mechanical waves. And for non-mechanical waves, non-mechanical waves means the name itself, it indicates that no medium is required. If there is no medium required, then how can it be propagated? For example, electromagnetic waves. Electromagnetic waves are the best examples for non-mechanical waves. Even though there is no medium, these electromagnetic waves can be propagated. Electromagnetic waves means nothing but the propagation of wave due to the oscillations of both electric and magnetic fields perpendicular to each other, usually perpendicular to each other. Okay, that we will discuss in the next coming chapters. So non-mechanical waves means no medium is required to propagate the medium, to propagate the wave. That is called as non-mechanical wave. Okay, and next one. So that is about mechanical and non-mechanical. Due to the vibration or oscillation of the particles also, the waves can be propagated, the waves can be categorized into two types. First one, due to the oscillation of molecules or due to the vibration of molecules or particles. Okay, these waves can be categorized into two types. These are nothing but mechanical waves. In these mechanical waves, again we are taking two types. First one, transverse waves. Transverse waves. And the second one, longitudinal waves. Longitudinal waves. What is meant by transverse waves? Suppose if the particles oscillate perpendicular to the direction of propagation of wave. If the particles propagate or if the particles oscillate perpendicular to the direction of propagation of wave, those waves are called as transverse waves. For example, if you are making 100 students to sit at one place, okay, they are sitting just to somewhat, okay, they are laying down. Now one by one we are asking them to just stand up and sit down. Okay, now then immediately if we ask another student to stand up and sit down immediately, so if one student will stand up and sit down and immediately he stand up and the other person stand up and sit down and immediately the other person, residing person, so like that, due to standing and again sitting immediately, if we observe the total thing at once, then we can observe that that motion as a wave form. A wave is going there, we can observe the generation of a wave. Got my point? A wave is being generated there, we can observe. How can you observe the wave generation in that example? Because of the oscillations of molecules standing and sitting, because about its mean position, because of oscillations of molecules about its mean position, Okay na? Then immediately, okay, the wave will be propagated perpendicular to it. So like that, if it is done like that, then we can call that type of waves are transverse waves. And longitudinal waves means, okay na, sound waves. Well, let us discuss about the sound waves. Suppose from my mouth the sound is generated once. Now the air molecules which are near to my mouth, okay na, they will take the sound energy and they used to go to the residing molecules. While they are going to the residing molecules, by taking this sound energy, compressions will occur. Okay na? Then at the time of compressions, what happens? They will give that energy to the residing molecules and they will come back. Means this is what we call elasticity, going to some distance and coming back, to and fro. This is what we call elasticity. So these medium, whatever it may be, whether it may be a transverse waves or it may be longitudinal waves, the particles should have elastic property. The medium should have an elastic property and the medium should have inertia. Based on these two properties, the wave will be traveled. Okay. So longitudinal wave, what is transverse waves? Oscillations of particles perpendicular to the direction of propagation of wave is called as transverse waves. We can see the examples in water waves. While the water waves are going like this, okay, now if you put a small paper boat on it, then this paper boat will oscillate up and down only. It doesn't go along with the wave. This paper boat will oscillate up and down. It does not go along with the wave actually. Okay now, this is, assume that this paper boat is a particle, so that this particle is oscillating about its mean position while the wave is propagated perpendicular to this. This is called as transverse waves. Longitudinal waves means, suppose if this is a propagation of wave, in this example you can observe. Here this is a propagation of wave as well as these springs, okay, are oscillating about their mean positions like this. Means the direction of oscillation is parallel to the direction of propagation of wave, is along the direction of propagation of wave. That is called as longitudinal waves. Example, sound waves in air or sound waves in any medium are the best examples for longitudinal waves. Okay. Now let us discuss the wave parameters. Let us discuss the wave parameters here. Wave parameters means what are we observing in wave motion actually. These are the physical quantities that we observe during the wave motion. These are called as wave parameters. First one, the first parameter is nothing but the amplitude. Second one, frequency, wave frequency, or else no problem, frequency. Third one, wavelength, Fourth one, time period. Okay, and fifth one, intensity of a wave, intensity of a wave. Now let me give you a brief details about this. What is meant by amplitude? Amplitude is nothing but in SHM you might have understood about it, right? If the particle displaces to maximum, that is called as amplitude. Means the maximum displacement of the particle during the wave motion is called as amplitude. Okay, the maximum displacement. See, for example, if we consider a transverse wave, see, this is a transverse wave. What does it consist of? It is a crest and it is a trough. Am I right? Right? So crest here, at this position, the particle will have a maximum displacement. This is called as amplitude, maximum displacement of the particle. Even here also, this is called as amplitude. Okay. Okay, now, even during longitudinal waves also we can say maximum displacement, but in the direction of wave. Okay, now that is about amplitude, and it is denoted with the letter capital A. Now what is frequency? Frequency means number of oscillations per second or number of waves per second. In the previous chapter oscillations were there. So there we used to discuss it as number of oscillations per second is called as frequency, and it is denoted with the letter F. And sometimes you might have heard about omega. This is what we call angular frequency. This is called angular frequency. F means linear frequency. Means number of oscillations per second is called as linear frequency. Then wavelength. Wavelength is denoted with the letter lambda. What is a wavelength here? Wavelength means the distance between the two consecutive crests, or the distance between two consecutive troughs. Simply we can say that what is the length of the total wave. What is the length of the total wave? Okay, now, or simply we can say the distance between two consecutive crests. This distance is called as wavelength. Or suppose if this is a next trough, then the distance between the two consecutive troughs is also called as wavelength. Length of one wave, simply. Now let us consider what is meant by time period. It is denoted with the letter capital T. Time period means the time taken for one complete wave is called as time period. One wave motion. Okay, now suppose if it is going to a distance of lambda, then the time taken is T, capital T. Okay, that is what we call time period. Then what is meant by intensity of the wave? It is nothing but it is the energy transmitted per unit area per second. Energy transmitted, how much amount of energy is transmitted per unit area per second is called as intensity of wave. Let us explain that in detail in the further classes. Okay, these are the wave parameters. These are the wave parameters of waves. Okay, in the next class we will discuss about wave function. Let us start with a wave function, and I will explain you what is a wave function and how do we there are some numericals about wave functions. Let us do that, and we will clearly understand about wave function. Okay, thank you.